Hi, today I'll be explaining Surds in less than 15 minutes. This is in section 1 of the Add Math syllabus, and I'll be explaining all of these objectives in detail, and I'll do some practice questions at the end of the video. Okay, so the first thing you need to know is that a surd is an irrational number that is the root of a rational number. I'm going to put some examples of surds right here, and what makes these surds is that these cannot be simplified into rational numbers, okay? If you place one of these in a calculator, it will simply return decimals that go on forever without repeating. I'm going to place some examples on the screen. Okay, this is the second thing you need to know about surds. This would be the two properties of surds that you really need to know. Okay, the first property would be that square root AB equals square root A square root B. That's the first property, right? And as an example, we could have square root 15. And we know that 15 equals 3 times 5. So we'll put square root 3 times 5. And this is where the first property comes in. We would put that would be equal to square root 3 square root 5. Okay? And then after this, we would have the second property of surds. So square root A over B would be equals to square root A divided by square root B. Yeah, and as an example, we could have square root 7 over 8. And that would obviously be equal to square root 7 divided by square root 8. Yeah. I recommend that you just jot these down because you really need to know these. Okay. Before we move on to addition and subtraction of surds, I think it's very important to understand what the general form of a surd is. Okay? This is a general form of a surd where k is the coefficient, n is the order of the surd, and a is the radicand. Okay, this is the very next thing you would need to know for surds. You need to know the general form of a surd because you can only add and subtract surds which are of the same order and radicand. You can add the first example shown because they are of the same order and radicand, but for the second one you cannot add them because they are of a different radicand. For the third, you would not be able to add them because they are of a different order. Okay, so here are some practice questions on adding surds. The first thing you want to do is make sure they're of the same order and radicand. Fortunate for us, this is of the same order and radicand, so we can just add them. Just like this. This would be the answer. And then for B, we would just do, we would have to simplify these because we can't just add them like this. So we would use first property of surds, which would be to do this. So 9 times 3 equals 27 plus, that would be 36 times 3. And then this would be 16 times 3. So after this, you just need to simplify. We already know that root 9 is equal to 3. So we have to put 3 root 3 plus, what's the root of 36? Square root of 36, that would be 6. So we would have to do this. And what's the square root of 16? That would be 4. So we have to put the 4 outside. Okay, now we have successfully simplified all of the surds. Now we just need to add the coefficients, just like we did right here. So And that would be the answer to this question. Okay, here are some more questions, except in this case we would be subtracting. As you can see here in A, these are surds of the same order and radicard, so we could just do 9 times 3 root 2 equals 6 root 2. That would actually just be it. Then for B, we can also see that these are surds of the same order, same radicard, so we can just do 8 times 6 root 3 equals 2 root 3. That's it. Okay, so let's move on to some harder questions where we would actually have to simplify the surd. Okay, here are some harder questions. Let's start off with A. So the very first thing you want to do is just simplify this. So pretty sure that 567 is equals to 81 times 7? I think so. So 81 times 7. Yeah, 81 times 7 minus whatever root 28 would be. That would be 4 times 7, yeah. 4 times 7 plus, that would be 64 times 7. Okay, so now we need to get rid of whatever can be square rooted. So the square root of 81, that's 9. So we would square root 81 and put the result outside of the square root. So that would be 9 root 7 minus... Okay, so this is a number that can be square rooted. So square root 4, we know that's 2. So put it outside the square root. That would be minus 2 root 7 plus... Identify the number. That would be... that we can just reduce by square rooting it. That would be 64. The square root of 64 is 8, so put it outside the square root. Put 8, then leave 7. Okay, now we can just simplify. So 9 plus 8 minus 2 root 7. We know that would be 15. So the answer is 15 root 7. Okay, let's solve for B. So for B, these two questions were very similar. For B, all we would have to do, we just do the same thing. So we know that 245 is equal to 49 times 5, I'm pretty sure. So yeah, and then we know 320 is equal to 64 times 5. Yeah. And then we know 405, that would be equals to 81 times 5. Yeah, 81 times 5. Yup. So now we need to get rid of the numbers that we can just square root. So square root of 49, that's 7. So put 7 outside the square root. Leave the 5 because we can't square root that. So let's move on to the next number. Square root of 64. We know that's 8, so put that 8 outside. Leave the 5. 81, square root of that. We know that's 9, so minus 9 root 5. Now we just simplify. 7 plus 8 minus 9 root 5. That would be 6. So 6 root 5. So the answer to B is 6 root 5. And that's it for addition and subtraction of surds. All right, if you made it this far, I'd say the next thing you need to learn is how to multiply surds. To multiply surds, you simply just need to multiply the coefficients by each other and the radicand by each other. And you may be asking, what do you mean by coefficient and radicand? Well, coefficient is just a number that stands right outside of a square root symbol, and a radicand is a number under the square root. So you see, for example, here's a question: 3 root 2 times 6 root 2. Alright, we've identified that they have the same radicand, and the coefficient of the first number is 3, coefficient of the second number is 6. So, all you need to do is 3 times 6, 18. Root 2 times root 2 is root 4. So your answer would be 18 root 4. Right. See how easy that is? Also, surds can be solved by using the distributive law. Say we have a problem like this, right? It's the same easy question, you know. You just need to multiply the coefficients by the coefficients and the radicards by the radicards. So multiply 3 times 4 and root 2 times root 3. That would be 12 root 6 plus 21, 10. Yeah. Now that you understand how to multiply surds, I'll be focusing on how to rationalize the denominator of a surd. Have you ever seen a fraction like this? It looks simple, but in math we don't really leave square roots in the denominator. We rationalize it, which means to get rid of the surd on the bottom. The trick to get rid of the surd on the bottom, all you have to do is multiply the top and bottom of the fraction by the same surd. That means you would do this. And once you do this, you'll be able to obtain root 2 divided by 2. So that would be your final answer. You successfully rationalize the denominator. And this would be what you write if you get a question like this. But questions won't be this simple. I'll show you how to do it with more complex. Okay, here's a more complicated question where you will have to multiply by the fraction by the conjugate of the surd. The conjugate of this surd would simply be root 3 minus 2. That would be the conjugate of this surd. So what you need to do is multiply this entire fraction by the conjugate of the surd, okay? So you would do 1 by root 3 plus 2 times root 3 minus 2 divided by root 3 minus 2. Okay? So the top of the fraction would become root 3 minus 2. And then the denominator would become root 3 plus 2 multiplied by root 3 minus 2. Okay? So you would then need to multiply them and bring the surd into its simplest form. Okay, here's a more complicated question where you will have to multiply by the fraction by the conjugate of the surd. The conjugate of this surd would simply be root 3 minus 2. That would be the conjugate of this surd. So what you need to do is multiply this entire fraction by the conjugate of the surd, okay? So you would do 1 divided by root 3 plus 2 times root 3 minus 2 divided by root 3 minus 2. Okay? So the top of the fraction would become root 3 minus 2. And then the denominator would become root 3 plus 2 multiplied by root 3 minus 2. Okay? So you would then need to multiply them and bring the surd into its simplest form. So that would be root 9. That would be okay. Once you've gotten to this point, you should realize that the denominator is just the difference of two squares, right? This denominator is equal to bracket root 3 squared minus 2 squared, right? So then that is just equal to 3 minus 4, right? And then 3 minus 4 is equal to minus 1. Therefore, you get root 3 minus 2 divided by negative 1, okay? But this isn't the perfect form. I mean, the simplest form. Please remember, you need to always put your answers in the simplest form when you're dealing with surds, or you can get marked down for that. So the simplest form would be that is equal to minus root 3 plus 2. Yeah, that would be the answer. Or you can put 2 minus root 3. Any of those answers would work. I just prefer this one because it looks cleaner. But yeah, that's how to rationalize a surd. And if you made it this far into the video, then you can probably tackle most questions involving surds.